started in machine learning today with no experience whatsoever, here's exactly what you're going to do. When someone says they want to get started in machine learning, it's important to take a step back and figure out what you're actually trying to learn. And that is how to think in math, how to think in data, and how to think in code. So here are the 5 steps you're going to take today to master those 3 concepts. Now, I know it sounds cliche, but foundations must come first. You should begin by making sure that you can write basic Python fluently enough that it feels more like a language in your mind rather than just memorizing syntax. This means you can manipulate lists and dictionaries, write functions, read and clean data from a CSV file, and plot simple graphs without constantly copying from tutorials. Definitely don't get overwhelmed at this very first step. There are so many amazing resources on the internet that can teach you to code in a very enjoyable way. At the same time, you should deliberately strengthen and review the parts of math that machine learning leans on most heavily. This includes linear algebra, basic calculus, and probability. Now, this is not to say that you need a crazy graduate level understanding before you start, but you should understand these concepts well enough that when you see them in an explanation, you aren't completely lost and can follow the logic instead of trusting it blindly. Next, it's time to grind on your actual learning of machine learning concepts. Once you've made it to this step, put your head down for a few weeks and really learn. One of the best starting points is Stanford's machine learning specialization course on Coursera. It walks you through course supervised and unsupervised machine learning method with enough math to build intuition, but always grounded in real-world exercises. On YouTube, Josh Darmer's StatQuest channel is pure gold for turning those scary-sounding concepts like gradient descent and neural networks into terms that intuitively make sense to you. This next part I cannot say enough, and that is that the key here is consistency. Commit yourself to whatever resource speaks to you most and really apply yourself to doing those lessons, taking handwritten notes, and actually understanding what you're being taught instead of just passively watching. Now, while you're learning, this next piece of advice is one of the best I can give, and that is to read other people's code and notebooks. In parallel with your own learnings, you should regularly read other people's work on Kaggle and GitHub, focusing on the structure and style these experienced coders are using. When you read a good notebook, you should notice how the author organizes the workflow, what libraries they choose to import, how they explore the data before modeling it, how they choose evaluation metrics, and where they print updates so that the logic is traceable. When I was learning, one of the things that helped me the most was looking at fully functioning models and literally going line by line and writing down in a physical notebook the purpose of each line and how it contributed to the model's greater goal. Every time you see a pattern that makes sense to you, you should try to imitate it yourself until you develop your own style. After all of this, it's time to make your first serious contact with machine learning code. Here you should move directly into simple supervised learning on real datasets, and this is 100% the step of the process where you will learn the most. Pick a small tabular dataset on Kaggle, for example, apartment sizes and their prices, a football team's first downs and their amount of points scored, or student study habits and their corresponding test scores. Walk through the entire pipeline in your head. Load the data, split it into train and test sets. Train a linear regression model and evaluate it with mean squared error. During this entire process, but especially during this step, AI is your best friend. Use platforms like ChatGPT or Claude to help you when you're stuck on next steps or help you figure out what bugs in your code actually mean. But while you're doing this, you should think in full sentences in your head about what is actually happening. For example, right now, I'm fitting a function that takes in these features and adjusts these parameters so that the loss on the training data is minimized. It's important to note that if you want to take a step up in your learning while coding these models, you should practice parallel tracking your learnings with theory explanations. In linear and logistic regression, this looks like understanding what a loss function is, why we minimize it, and how gradient descent moves parameters downhill. Reading from one good machine learning course and then immediately re-implementing those ideas into your own code will do way more for your understanding than watching endless videos. So get that one course in and then get coding. Now it's time to specialize. Once you've built this general foundation, choose 1 or 2 sub-areas to explore more deeply, such as neural networks or random forests. In your chosen area, you follow a sequence of increasingly serious projects, and each one pushes you to learn more. As you specialize, you should keep those habits you developed while learning the fundamentals, constantly asking how this new technique works and how it relates back to what you already know. Lastly, interact with the community. Throughout this journey, you should deliberately avoid doing it in a vacuum. Instead, you should share your work, your questions, and your confusions with people. This can mean posting project write-ups online, asking questions in a forum, joining a study group, or even teaching small pieces of what you know to your friends and classmates. Every time you explain something to someone else, you will feel exactly where your understanding is shallow, and that discomfort will show you what to revisit next. And with these 5 steps, you're not just learning ML in the abstract, you're actively training yourself to think in math, data, and code. So each week, you're a little bit less of a spectator and more of a builder. Don't forget to save this video for your next machine learning endeavor and follow for more.